Okay, thanks, Andy, and thanks, Paula. Thanks especially for the geological place setting note. So my task here is to provide some updates from the integration facility before we dive into the keynotes. Before I do that, I think it's important to acknowledge that this has been a tough year for science across the U.S. We all know people have lost grants or had grants delayed, or in some cases, some of our federal colleagues have actually lost their jobs. So it's important to be aware of that. Despite that, I actually feel really optimistic about the future of this community and the science that we do. Not just because our Congress has elected not to deeply slash the science agencies so far, but also because I know what you all know, which is that scientists on the whole are probably the most tenacious and creative and resourceful people on the planet and tend to find a way to make things happen. And I was recently thinking this when I came across the story of some of the folks who came before us who had to deal with difficult times. So I just wanted to very quickly share one story that I personally found inspiring. And it's the story of Milutin Milankovitch. We remember him today as one of the fathers of climate orbital theory. But in 1912, he was a young professor at the University of Belgrade, just starting out his career. He's an engineer, and he gets interested in theories of climate, and he starts to work on that. 2 years later, he's on his honeymoon when World War I breaks out, and he gets arrested by the Austro-Hungarian Empire. And he's hauled off to Budapest, thrown in jail briefly, and then apparently on some kind of a house arrest, but he's allowed to work at the library. So he just keeps pushing forward on his ideas around orbital theory. By 1919, the war has ended. He's back in Belgrade, and he cranks on with various projects that ended up making up his career until in 1941, he had written a complete manuscript on his opus of ideas about climate and Earth's orbit called A Canon of Insulation and the Ice Age Problem. The manuscript is almost lost when the Nazis bomb Belgrade in 1941, but somehow he manages to preserve it, gets published that year. So we look back at World War I and World War II, which he lived through, as kind of these tragic but somewhat distant events in history. But of course, the science that he worked on is still alive and well, and part of our understanding of how the Earth system works. And to me, this is a reminder that, we're all, by virtue of doing science, immediately part of something that's much bigger than ourselves. This multi-generational project that started before we were born and is going to continue after we're gone and is building out human knowledge. And when I think of it that way, I just think I'll be darned if I'm going to let a bunch of knuckleheads dissuade me from playing some tiny role in that big and beautiful project. So anyway, for what it's worth, CSDMS has been fortunate this year. The integration facility has been fully funded by NSF, so we've been able to continue moving forward. Since some of you are new to CSDMS, let me say a few words about what it is. So it's really kind of three things at once. It is, first of all, a modeling system, not a big monolithic heavy machinery modeling system, but a lightweight kind of plug and play component-based thing. It's a community, so it's all of us here and 2,500 other people around the world. And it's a facility, so it's a handful of folks in Boulder, Colorado who do work in computing, community education, that sort of thing, to try to make the science that you all do a little bit easier and more efficient. So I'll go through a few things that CSDMS provides. One of them, as you know, is the so-called model repository. So this is the online portal where you can kind of park your codes and share them with the world. We're up to 453 models and tools in the repository. One of the things that we've been just starting to develop now is for a small select handful of these models to provide a one-click launch capability. So for a few of these models, you'll notice if you page down on the model description page, you'll see a little button called Run on Earthscape Hub. And if you click that, it will launch a login page onto the Earthscape Hub. I'll say more about that in a second. So online Jupyter Hub hosting platform, and you'll open to a tutorial notebook where you can actually try out that particular model, run it with example data, and so on. As I say, just a few models we've done this for so far, but if you have a model in the repository you'd like to add this capability to, let us know, and we'll try to work with you to make it happen. Speaking of the Earthscape Hub, so you all have logins on that. If you didn't have one before, you do now since you registered for the meeting. And if you didn't have one before, your login will be your email address, whatever email address you used to register for the meeting. And this will be used for a bunch of the clinics that'll follow over the next 3 days. So let's see. So let me say a few words about LandLab. Many of you know about LandLab and have contributed to it or used it in various ways. For those who are new to it, this is basically a Python language programming library that's designed to make it quicker and easier and more efficient for you to write 2D grid-based numerical models. So basically anything that you could represent with a numerical algorithm on a 2D grid is fair game for LandLab. And the way it works is you can create a grid object in one line of code and then add layers of data to suit your application, maybe water depth or land surface height or temperature or biomass or whatever. And then either cook your own numerical routines or use some of the built-in numerical routines to create a solver. One of the things that makes LandLab useful and very kind of a community grassroots kind of product is the idea of components. So a component is just a chunk of Python code in a standard format that does like one thing. So one thing might be, solving a diffusion equation numerically, or an advection equation, or calculating solar radiation on the terrain, or calculating evapotranspiration, or whatever it might be. So thanks to those of you who have contributed to this growing library of components, I want to highlight some of the work that's been done with LandLab over the past year. So we try to keep track of publications that people have done using LandLab in one fashion or another, as well as other CSDMS products like BMI and so forth. Here's the list that we have so far for 2025. It's online. If you don't see your favorite paper in here, you can post an issue on the GitHub site, or you can, even better, do a pull request to add it yourself. That's always great and welcome. I'll highlight just a few of these. There's like 30 of them here, but just to highlight a few. Jeff Keck has a really cool study on modeling landslide susceptibility in snowy mountain ranges. Nicole Gasparini with Tengun Lee and Leonard Sklar have a really cool piece about how hill slope grain size distribution influences large-scale landscape evolution. Joe Mason and friends have a really neat piece on loess tablelands and how they evolve in these kind of mid-continent loessy landscapes. Angel Monsalve has a cool new component called riverbed dynamics I think we're going to hear more about this morning. Laurent Roberge has a cool new paper that just came out earlier this year that explains how you can use components to track constituents that travel with sediment. So like, detrital zircons or organic carbon or anything that moves with the sediment. And then Yuval Shmulevitz and friends have a paper from earlier in 2025 that basically demonstrates how you can model soil erosion and gullying due to intense rain bursts and yet integrated over timescales of like centuries to millennia. So those are just a few. You can take a look at the full list. A quick word about educational programs. So I think many of you know about the Earth Surface Processes Institute. So this is this roughly week-long training program that we put on every year for early career scientists. Basically, a program focused on scientific computing and numerical modeling. So we'll have another run in August this year of that. If you've applied to the program and not gotten in, know that you're not alone. One of the limitations is we haven't had the resources to keep up with demand. So just about every year, Irina and her team have had 3 or 4 times as many applications as we have slots. So, we would love to have more resources to expand this in the future. In the meantime, there are some alternatives to consider. One of them is we've been doing a roadshow program. So this is basically where 2 of the research software engineers from the CSDMS team will go to your institution and put on like a 3-day workshop on scientific computing and programming and use of CSDMS tools. We've been doing about 2 of these a year. If you want to host a roadshow, let us know. We don't have infinite capacity, but we've got probably 3 more of these in the next year and a half. So we would love to work with you to set this up. Then too, there's a bunch of online resources that I think many of you know about. And I won't go through all of these, but I'll just point out a couple. I mean, one is if you want to connect directly in person with or sort of in person with a research software engineer, you can sign up for office hours where you do a video call with one of our engineers and can work through whatever kind of computing challenge you're working on. There are also a bunch of online asynchronous kind of self-paced learning materials, both on like sort of fundamentals of scientific computing and programming and also on some domain-based stuff. So one question I get a lot is, how can I get more involved with CSDMS? And so here's a list. Muriel, wherever you are, there's a list. I won't go through all of these, but there's a lot of ways to get involved. One of them is to do code reviews. So we always welcome people to do code reviews. So if somebody has like created a new component or a new piece of software, it's really important that it's reviewed by one or more people before it's pulled into the main repository. So we always, and like, a lot of time the integration facility does this, but we always welcome others who want to volunteer to do code reviews. It's a fun and fairly painless process. And of course, contributions to the software and the educational repository are great. CSDMS is really meant to be both by and for the community. That is, this collection of tools that are written collectively by all of us and sort of taken care of by all of us. So thank you to the, many of you who have already contributed tools and resources. I know that sometimes if you're not familiar with the process of kind of creating a new version of a sort, adding a little component or a piece of software and then having it kind of tested and merged into the main version, we've put together a video that basically walks you through how to do that process. It's online under the webinars collection, and it uses a kind of a real live simple example to demonstrate how that works. Basically going from an initial kind of make a version of the code, make some additions or modifications, and then get it merged back in. Okay, I want to lastly say a few thank yous. First of all, to the staff of the integration facility. Can you guys raise your hands, wherever you are? So these guys have worked hard all year round to make all these resources and programs available. I don't know if Lynn is still outside, but special thanks to Lynn McCready for really being the power behind organizing these meetings every year. I also want to thank our science program committee. John and Carrie, Eric, Muriel, and Andy. And I want to say a big thanks to our executive and steering committees. Can you guys raise your hands just so people can see where you are? So these are the groups that provide high-level leadership and guidance to the whole project. So, okay, so here's kind of a map of our 3 days together. We'll have keynotes in the morning. As Paula mentioned, we'll have breakout sessions on various themes over in the latter half of the mornings. One of the things that's especially important this year is we're trying to gather feedback and input and ideas from all of you to help shape the next iteration of CSDMS going forward. So people will be taking notes and recording things, and just know that this is going to become part of whatever the vision ends up being for the next round. We have clinics in the afternoons. If you've forgotten which clinics you signed up for, just look at the back of your badge. It should say. We've got a poster sessions today and tomorrow afternoon, an awards banquet tomorrow afternoon and evening, and then we'll wrap up with a Science Collider event. We'll say more about that as we go forward. But I think that's all I have for now. I'm happy to take any questions if there are any. Otherwise, I'm going to hand it over to our moderator for this morning, who is